Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the 8th part. In this part, we're supposed to determine the standard equation of the hyperbola where given the coordinates of the two vertices and the eccentricity. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola. Before we jump into this example right here, let's have a review on the parts, the two cases, and the equation of hyperbola. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus. And there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices, and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, a, b, and c, is c squared equals a squared plus b squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is c over a. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, going back to the problem right here. So we are given the vertices of the hyperbola, which is located at -5, 0. So this is our first vertex, and the other vertex is at 5, 0. We go ahead and remember that the center of every hyperbola is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So in this problem right here, our center between these two vertices is the 0, 0 or at the point of origin. So I'm going to go ahead and label this as our center. Now if you notice this, these two vertices are horizontal with respect to each other with center at 0, 0. So that we can go ahead and say that this hyperbola is an example of a horizontal hyperbola with center at 0, 0. So I'm going to go ahead and write that information up here. Since this is an example of a horizontal hyperbola, we remember that the general formula for every horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, we remember that A is the distance from the center to the vertex, while B is the distance from the center to the co-vertex. In this problem right here, we can determine the value for A. A here would be the distance from the center to the vertex. So that would be 1, 2, 3, 4, 5. So I go ahead and write that up here. Our A is equal to 5. And we don't have a value for B. So I go ahead and plug in the 5 down here. So this equation would come out. Again, since we don't have a value for B, I left this blank. Now, we are given the eccentricity, and so we get our value for B from here. So I go ahead and write the formula for eccentricity, which is E equals C over A. So we plug the values in. Our eccentricity is square root of 41. So that's square root of 41 over 5 is equal to C over A. Please notice that our A is equal to 5. That's what we got. So therefore, we can go ahead and say that our C is actually equal to square root of 41. So I go ahead and write that down here that our C is actually plus minus square root of 41, or this is approximately plus minus 6.4. So we go ahead and plot this C value, which is 6.4 on this graph right here. We remember that the C is the distance from the center to the focus. So that's 6.4. So this is negative 5, negative 6.4 should be somewhere around here. So this is our first focus, and the other focus would be 6.4 to the right. That's 6.4. This is our second focus. So that we go ahead and write the coordinate of these two foci. So these are the coordinates of these two foci. But we haven't solved the problem yet because we're supposed to determine the equation of the hyperbola. However, we don't have a value for B, though we have solved for C, but we don't know the B. Now, we remember that the equation that relates A, B, and C is C squared equals A squared plus B squared. So I'm going to go ahead and write that up here. So we already have a value for C, which is square root of 41. So I plug it in. So square root of 41 squared equals our A was 5. I write 5 squared plus B squared, the one that we're looking for, and we don't know what it is. So we go ahead and write our B here as blank. We don't know what that is, and we can solve it from here. So square root of 41 squared is 41 equals 5 squared is 25 plus B squared. So I go ahead and subtract 25 from both sides, minus 25. So then we can cross the 25 out. We're left with B squared is equal to 41 minus 25 is 16. So I'm going to write 16 right there. So then our B is plus minus 4. That means our B here would be 4. And remember that the B is the distance from the center to the co-vertex. That means I will go up 4 and down 4 to locate the two co-vertices. So that would be 1, 2, 3, 4. This is our first co-vertex. 1, 2, 3, 4. This is our second co-vertex. So we can go ahead and write the coordinates of the two co-vertices down here. From here, we can go ahead and draw the central rectangle of this hyperbola. Okay, we remember that the central rectangle should cover the two co-vertices and the two vertices, so that we can go ahead and draw the two asymptotes. The asymptotes would connect the two corners of the rectangle passing through the center. So these are the two asymptotes. Okay, now let's determine the equation of these two asymptotes. We start with a negative slope asymptote. So remember that the equation for the asymptote, there's again a formula for this, but we don't have to memorize the formula. We can just go ahead and count the values to get the slope. And then this problem here, we go up to the corner of the rectangle. So 1, 2, 3, 4. So I went up 4 over, I went to the left, 1, 2, 3, 4, 5. So that would be a negative 5 because I went to the left. So this is the equation of the asymptote with a negative slope. The one with a positive slope, it's pretty much the same thing. Y equals, we go up to the right. So 1, 2, 3, 4. So I write 4 over 1, 2, 3, 4, 5. And we write X next to it. So these are the equations of the two asymptotes. Now we can go ahead and determine the length of the transverse axis, that is the distance from the vertex to the other vertex, and the length of the conjugate axis, which is the distance from the co-vertex to the other co-vertex. I'm going to show the work up here. Okay, so the length of the transverse axis is 10, while the length of the conjugate axis is 8. So then we can go ahead and sketch the hyperbola. Okay, and finally, we can go ahead and write the standard equation of this hyperbola. We missed the b squared here, however, we solved it, so we're gonna plug it in. So this is 4 squared. So then our equation then would be x squared over 25 minus y squared over 16 equals 1. So this is the equation of this problem that we have up here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We are given the vertices, and so I'm going to go ahead and plot these two vertices down here. Now we remember that the center of the hyperbola is the midpoint between these two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So looking at this, our center is at 0, 0, or at the point of origin. Now looking at this, since these two vertices are vertical relative to each other, so then this is an example of a vertical hyperbola with center at 0, 0. So I'm going to go ahead and write that up here. Since this is an example of a vertical hyperbola, the general equation for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now we remember that a is the distance from the center to the vertex. So looking at this, our a value is 1, 2, 3. So then we write 3 there, and so this equation would come out. I left the b squared blank because we don't know what it is, but we are given the eccentricity. So I'm going to go ahead and write the formula for eccentricity up here. So eccentricity is equal to c over a. We plug the value in, that is square root of 58 over 3 is equal to c over a. Again, looking at this, our a was 3. And this tells us that our c is square root of 58. And so I go ahead and write that down here that the c is plus minus square root of 58, or this is roughly 7.62. So that is 7.62. So I go up, since this is the vertical hyperbola, our two foci would be up 7.62 and down 7.62 from the center. So I'm going to go ahead and plot those two foci right here. Okay, from here, we are going to solve for b because that's what we needed here to complete the equation of this hyperbola. We're going to use the equation c squared equals a squared plus b squared, and we can solve b from there. So I'm going to show the work down here. Okay, we've solved the value for b, which is 7. Again, we were using the c squared equals a squared plus b squared. This means that we go to the left 7 steps and we go to the right 7 steps to determine the co-vertices. And I'm going to write the coordinates of these two co-vertices down here. Okay, so we can go ahead and draw the central rectangle of this hyperbola, and we can go ahead and draw the two asymptotes. Okay, so I have determined the equation of the asymptote with a negative slope. That is 3 over negative 7x. Again, I go up 3 and 7 to the left. That's how I got negative 7. And for the positive slope asymptote, that would be go up 3 and then to the right 7. And so this is the equation that we have right here. So we go ahead and determine the length of the transverse axis, that is the distance from the vertex to the other vertex, and the length of the conjugate axis, that is the distance from the co-vertex to the other co-vertex. I'm going to go ahead and show that work up here. Okay, so the length of the transverse axis is 6, while the length of the conjugate axis is 14. So then we can go ahead and sketch the hyperbola. Okay, since in this problem we're supposed to determine the standard equation of the hyperbola, we already have the a value, we have the b value as well. So we go ahead and plug that in here. So our b is 7 and we're going to square it. So our equation is y squared over 9 minus x squared over 49. So this is the equation of this problem. This is, by the way, equal to 1. And so again, this is the equation for this problem that we have up there. And this is the graph of this equation. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya.